Recently we worked on a project where we modeled wind patterns at CenturyLink Field in Seattle. So in this video we'll show you how you can visualize wind behavior inside a stadium like that using Autodesk Flow Design. So we'll start by bringing in a 3D model of the geometry. Flow Design can read in lots of different kinds of files. This list includes neutral files like you might use for 3D printing. There's native CAD format file imports, and then you can also use 2D images if you want. So Flow is going to come in from the northwest and then go through the stadium and exit on the southeast. So in this case, what we see on this 2D slice through the model is air sort of coming through the stadium. It's moving around that vertical pillar there, and then it sort of collects on one side. So we've got a lot of high-speed flow on one side of the field, but relatively slow-moving and recirculating flow on the other. So here we're going to be looking at what we call flow lines through the model. So these are a 3D representation of the airflow. It's as if we had a large smoke wand and we introduced it into this virtual wind tunnel so that we can actually trace the movement of air through the actual stadium. And so yeah, we see it coming in. It tends to sort of collect on one side, and then we have this big vortex behavior that results. And you can imagine if you're a kicker or a punter or even a quarterback, this is going to make it difficult to move the ball and put it where you want it on the field. So this is just one condition though. Flow Design makes it really easy to change the wind speed or the direction. So here we're just going to key in a different value for the wind speed, and the calculation will update with the value that we've put in. If we wanted to change the orientation, we can just flip it around using this orientation control. Now, when people test buildings like this in physical wind tunnels, what they do is they have them on a rotary table and they just turn the scaled model around, much like we did here in Flow Design. So it's sort of the same type of workflow, but in a totally virtual environment. And what we're going to see here are the results start to update. They're going to take into account the new wind speed and the orientation that we've put in, and we'll find out if the extra blockage that we get from the stands on the south side of the stadium helps out when the wind's coming in from this direction. So it looks like the result is starting to develop here, and again we do have a concentration of fast moving airflow on one side of the field. This time it's on the western side of the field. So despite the extra stands and the signboards on that side, which you might think would contribute to some extra blockage, it looks like we still have something to contend with when the wind is coming from that side. If I put some flow lines in here and sort of see them in a similar spot, yeah, we do see that air is jetting through there and creating that same type of vortex behavior when the wind is coming from the opposite direction. So Flow Design is really useful for quick studies like this, where you're just looking to get an understanding of how wind will behave when it moves around buildings or other kinds of objects. It'll help you figure out where wakes are going to form, how large they'll be, where flow will tend to recirculate, and where you're going to have high and low pressure regions. So if you're interested, you can get access through our online store, or you can register for student use on the Autodesk education community. Be sure to check it out.